Okay, good morning. So today we'll continue some more examples. So yesterday in the last class we discussed two examples of hexagon pyramid, how to draw the initial shapes, second and third position. One more example we will try this class. So what is the question given? A hexagonal pyramid of 25 millimeter size of base and 60 millimeter axis length rests on HP and one of its edges of the base, which is inclined to VP at 30 degree. It is not 300, it is 30 degree. So hexagon pyramid, the side base of the side is given 25 millimeter and axis height is given 60 millimeter, and the same base side at the last the position we have to incline at 30 degree, and as usual draw the position of the pyramid when the axis is inclined to HP at 45 degree as given. So since he has given the edge condition, so it is resting on one of his edges of base on HP. You construct the hexagon such that the edge should come right side of you. You construct the hexagon such that the edge should come right side of you. Okay, and then so you know how to construct the hexagon with the help of the circle method. You can construct it. So after this, you name it. So in your own way, you can name it and draw the opposite corners. That is, join a line, diagonals, opposite corners. So all meet at a single point. So that is nothing but the center of your hexagon. Okay, because in the top view, the hexagon pyramid, those slant edges will look like a diagonal lines. Okay, so you name the base point as the O1 and apex point as the O. So after construction of your top view like this, then you have to keep on draw the vertical projectors from all the points. Okay, so like this you draw the vertical projectors from all the 3 points, and then extend the axis line. From the axis line you draw the vertical projector line, and then axis height is given 50 millimeter. You take 50 or 60, whatever it is given, you take that and then cut it on that vertical line and call that as a vertex point or the apex point. Vertex or the apex point. After getting this vertex or the apex point, join all the corners at the points, you join it. So this completes your the front view. So and also here the axis line you cannot see here, but axis line it is there here, O2 O1. I cannot show because so visible it will coincide with the axis line, and you are looking from the front side of it. ABC you can see outside the bracket, you can write. DEF you can write within the bracket, that you cannot see. So that's all. So this completes your initial position or the front view and top view of the first position. Next, the second position he has given, the axis is inclined at 45 degree, correct? How much he has given? Axis is inclined at 45 degree. So you're all familiar with this concept. Axis and base are mutually perpendicular to each other. So mutually perpendicular to each other in the sense, if the axis is 45, the base should be 90 minus 45. So that's what I have taken. So you take right side any point on the XY line, take any point on that and draw a 45 degree line, that is base inclination left side of you like this. After drawing this, you have to redraw this triangle, the front view of the triangle such that, so this base should come on this 45 degree line which I have drawn. So you name this, the point that you have taken on which you have drawn the 45 degree line base inclination, A dash and F dash you can name it. After this, take this length and this length and cut it on this 45 degree line and transfer the corresponding points also. The complete base you have shifted. Now from this, the over, you draw a perpendicular line with this. Draw a 90 degree line to this base inclination, that is 45 degree line, and this perpendicular line you take the height of the pyramid. You take this height of the pyramid and cut it on this. So wherever it cuts, you call that as the apex point, that is O dash. So after getting this point, you join all the points with respect to vertex or the apex. That means so you are redrawing the previous front view of the triangle such that the base should be inclined at the 45 degree line, And then since he has given the axis inclination is 45 degree, so this axis O dash to O1 dash, extend it till it meets the XY line, and write name that the axis inclination you have to denote there. So it is 45 degree. Show that axis. So this completes your the front view. So after this, so you have to draw the top view. For this, you have to keep on draw the vertical projectors from all the points of your front view like this, and then horizontal projectors from all the points of your the previous top view like this, and coincide the corresponding points. A is here, A dash is here, this is A. B is here, B dash is here, this is B. C is here, C dash is here, this is C. D is here, D dash is here, this is D. E is here, E dash is here, this is E. F is here, F dash is here, this is F. After coinciding all the points, and even base point is over, the axis base point O1 is here, O1 dash is here, this is O1. O is here, apex point, O dash is here, this is O. Now you join all the base points A, B, C, D, E, F, as well as from all the corners you join this apex also. Now you are looking from the top. Just look at this. You are looking from the top. Coming to the base edges, CD you can see. CD you can see. C to B and D to E. It becomes outermost boundary line you can see. And A to F, since it is resting on HP, that you cannot see from the top view. A to F as well as the connecting edges of that is A to E as well as A to B. So this and this base edge you cannot see. That means 3 base edges you can see, the 3 more base edges that you cannot see. So after this, coming to the slant edges, so all the corners of the base should be joined to your vertex or the apex, right? So you're looking from here, C to O you can see and D to O you can see, so it is very nearer to you. C to O is visible edge, D to O is also visible edge. E to O as well as B to O, it is seen, and also it becomes outermost boundary line or the outline of the drawing. And what about this A to O and F to O? Can you see that? You are looking from the top. You cannot see. So that's why F to O as well as A to O slant edges are the hidden edges. Show these edges as the hidden edges. And axis line as usual, O to O1, you represent the axis line representation. So this completes the top view, second position top view also. The third position what he has given, the edge which is resting on HP, the same edge is inclined at the 30 degree to VP has given. So that's one. So this is the edge. AF is the edge which is resting on HP. The same edge is resting on the inclined at 30 degree to VP, he says. So what you do? So you take any one of the point on XY line. Here I have taken little bit below the XY line so that the views or the top views or the corresponding views won't overlap or crosses each other. That means I have taken below the XY line on horizontal line, and I am taking 30 degree from this line. If this 30 degree is there with respect to this line, so definitely if you extend this line, the same line is having 30 degree with respect to your XY line also, or directly you can take 30 degree from XY line only. In any direction you can take. First draw the 30 degree line from the right side XY line, any direction. Okay. After drawing 30 degree line, you have to redraw the apparent shape of this top view such that AFX should come on the 30 degree line. So in planes also you have done this, as well as in the pyramid also you have done in many cases. First on this 30 degree line, you take any one of the point and call that point as the F point. Okay. After calling it as F point, take this F to A, F as the center, you cut this 30 degree line. So on this 30 degree line, I have fixed AF base edge, which is inclined at 30 degree to VP. So this I have done. So after this, how to get other points? So you can use any method. What you can do? From F and A, you can draw a perpendicular line like this, which I have not drawn here. You can draw a perpendicular line to this 30 degree line from F and A. So you take this F to D distance and A to C distance you can take. You can cut those 90 degree lines. So you will get see D as well as C you will get. So once again, if you are going with the box method, so from here, from this point, you can draw a perpendicular line. From this point, you take from A to this point, you take in between F, mention this point, take this point and draw a perpendicular line or 90-degree line. And that 90-degree line, this distance you take from here to O distance you take. Here you cut this 90-degree line. Similarly, from here, just O1 distance you take, and from here you cut it. So O1 as well as O you can get. Okay. After getting this O1, from this point O1, you draw a perpendicular line to this axis line. Okay. Draw a perpendicular line like this, and this perpendicular line O1 to E or O1 to B distance you can take. O1 you can cut this, from O1 you can cut this side, or else you can use the arc method also, whichever is easy for you, you can use that. Okay, so all the points you are getting it here, and without changing anything, including the visible edges as well as the hidden edges, you have to redraw it such that AF, the edge which is resting on HP, should come on this 30-degree line. This you have to do it. After this, so to get the front view of this, the final position, keep on draw the vertical projectors like this. Keep on draw the vertical projectors from all the base point 6 and axis 2.8 points like this, one by one. After this, you draw the horizontal projectors also from all the points like this, one by one. Horizontal projectors also. And then after that, you coincide the points. So where is A? A is here, A dash is here, this is A dash. B is here, B dash is here, this is B dash. C is here, C dash is here, this is C dash. D is here, D dash is here, this is D dash. E is here, E dash is here, this is E dash. F is here, F dash is here, this is F dash. O1 is here, O1 dash is here, the base point O1. Apex point O is here and O dash is here, this is O dash. After getting all the points, since in almost all the examples, so we are taking this apex towards the XY line so that the entire base you can see, correct? The base you can draw the visible edges, A dash, B dash, C dash, D dash, E dash and F dash. And coming to the slant edges, you are looking from here. You are looking from here. So which are all the slant edges is near to you? B to O you can see, B dash to O dash you can see, and even it becomes outermost boundary line. So you can mark it as a visible edge. C to O also you can see, where is C to O? C to O is seen, and D to O is also seen, it becomes outermost boundary line, D dash to O dash. Can you see the E to O? We cannot see since you are looking from here. E to O, it is behind you, that's why it is hidden edge. E dash to O dash. F also you cannot see, it is behind you. F dash to O dash is hidden, and even A to O slant edge also you cannot see, so that is also hidden edge. And coming to the axis line, O1 to O, you can join it, O dash to O1 with the axis line representation. So this how you have to complete the projection of this. So how many examples as of today we have discussed? Three examples in all the pyramids we have discussed. 3 examples in the square pyramid, both the corner condition as well as the edge condition, and 3 examples in pentagon pyramid we discussed, and 3 examples in the hexagon pyramid also we have discussed. The concept, procedure and principles, everything remains same. Only thing is you have to read the question, and according to that you have to draw all the 3 positions one by one. After drawing the true shape diagram, second position, then the third position you have to draw. Okay, so the simple cases of all the pyramids we have discussed. Now, so 2 more examples we'll be discussing today. So here it is the special cases or special type of examples. Okay, that means, so till today's class we have discussed it is resting on HP, resting on HP on one of its corner or base, and then axis is inclined like that. Now a case we will discuss, the pyramid is freely suspended from any one of the corner in this space. So such kind of questions, 1 or 2 examples we'll discuss. So one by one. So let me take a simple one first. So what is that? A pentagon pyramid, let me take example. So a pentagon pyramid of base 25 millimeter and axis height 50 millimeter long is freely suspended from one of the corners of the base. Draw its projection when the axis appears to be inclined to VP at 45 degree. So that means, so this is your pentagon pyramid, which is having 25 millimeter base and axis height which he has given it is 50 millimeter, and he says is freely suspended from one of the corners of the base. How many corners you have? The base you have 5 corners, so it may be freely suspended from any one of the corner. So you have, for freely suspended type of special cases of problem, you have to consider the corner condition only, because at the corner only I can suspend it like this. Okay, it is hanged or suspended at the corner like this in space. Okay, so that means for all freely suspended examples, you have to take the corner condition only, and with this position we have to draw the projection. So first, so since it is, he has given the pentagon pyramid of 25 millimeter base and axis 50 millimeter, you draw the pentagon first, the corner condition, that means to say such that the corner should come right side of you. I have drawn the pentagon for this particular case such that the corner is coming on my right side. You know how to draw the pentagon, you draw it such that the corner should come right side of you. After that, you bisect any two lines. Bisect any two lines. How to bisect, you know, take more than half of this, any two sides, and cut an arc from both the sides. From that intersection you join it to the opposite corner, like that. Any two sides you can do it, that is enough. Wherever these two, the line intersect, so that itself is your center of your pentagon. After getting the center of your pentagon, you need to join all the corners to your the uh, the center point. So like this you have to do it. After doing this, front view as usual in 3-4 cases we have drawn, it is same. How to draw the front view? You draw the vertical projectors from the all the points of your top view like this till it meets the XY line, and then which is the axis point, extend this axis point vertically upwards like this. Axis height how much he has given? 50 millimeter. You take 50 millimeter and cut this axis line. Wherever it cuts, call that as the apex point, that is O dash. Call that as the apex point, that is O dash. After getting this apex, so you join all the points with respect to your the vertex or apex completed. So your the front view is ready. Now in this case, so since he has given the entire pentagon pyramid is freely suspended from any one of the corners of the base. So I will take here, because I have considered the one of the corner as the A on my right side. So I will suspend freely this pyramid with the help of this corner, base of the corner A only. And then further a small constructional work that you have to do. All of you listen carefully. Okay, before going for the second this step, we need to do some constructional work. How to do it? So we need to find out the center of gravity of this pyramid first before proceeding to the second case. Okay, so center of gravity for the all pyramids in general, it lies exactly the axis line only. The axis line only the center of gravity lies, and then that too in the axis line 1/4 the distance from the base if you take, then only I can get the center of gravity. Once again I will repeat it. So this is your axis line now. This is your axis line. What is the axis height here? 50 millimeter. 1/4 of the axis means how much? 50 divided by 4. It is 12.5. Correct? So you take 12.5 millimeter from the base. You cut this axis. You cut this axis and call that as the center of gravity G point. I am calling it as G dash. Why? Because it is front view. Okay. So this how we have to find out the center of gravity of the any pyramid, whether it is square pyramid, rectangle pyramid or pentagonal pyramid or the hexagon pyramid. This once again I'll repeat this. So the center of gravity of the pyramid lies in the axis line, and that too 1/4 of the distance in the axis taken from the base. From the base you take 1/4 distance of the axis, that is 50 millimeters given. 50/4 means 12.5. You take 12.5 with the help of your compass. From here you cut it here on the axis line. Wherever it cuts, you call that as the center of gravity point. So that is G. Call that as a G point, G dash, because it is front view. And join your corner that you have taken on your right side, that is A. You corner that is A dash, you join it to G dash. You join the center of gravity point to with respect to the corner that you are freely suspending it. Okay, so you join A dash and G dash. This is the constructional work that you have to do in your front view. Next step, how to suspend freely, I will teach you. Next slide. So here what you do, so you take any one point on the right side. You take any one point on the right side. From that point take some height. Okay, so that the drawing should not touch or cross your X file, because it is freely suspended like this. So you have taken the right side. So for your right side you have taken the corner here like that. You have drawn the front view and top view. Next position, how we are doing it means this corner you are freely suspending it like this. Okay, you should not touch the X file like this. You are suspending it from the corner. How to do it? You take any one point on the right side, take certain height here, and call that as the corner where you are freely suspending in space, and I'll call it as the A dash point. Okay. Now from this A dash point, I'll draw a vertical line that is perpendicular to XY line. You draw a vertical line from this A dash point. Okay. You take any one point, the right side, and call that point as the A dash, and draw a vertical line from A dash. Draw a vertical line from A dash or perpendicular to XY line. Okay. After drawing this, you take this A dash to G dash distance with the help of your compass, the construction work, whatever you have done here. From this A dash as the center, you cut this vertical line and call this as the G dash. And call this as the G dash. So A dash and G dash, I got it. This vertical line. What I need to do is, I need to redraw the entire triangle such that this A dash and G dash should coincide on this A dash and G dash. So like this, you have to redraw it. So all of you understood this, how to fix up this A dash and G dash. Once again, I'll explain. You take any one point on the right side, call that as the A dash. Draw a vertical projector line or perpendicular line to XY line. Take this A dash to G dash distance and cut this vertical line and call this as the G dash. Okay. After getting this, I need to get the other points also. How to get the other points now? So how to get it? Only I know the A dash and G dash I know. Correct. So after this, what you can do is from point G, you take this distance, that is C dash and D dash. From here, point G, you cut an arc somewhere else here. Okay. And then from point A dash to the C dash D dash, you take this distance. From here, you cut an arc. So join this line. So you're going to get C dash D dash. And then on this line, you take this A to O1 dash distance, cut it here, mark that point. And then A dash to B dash, E dash you take and mark that point. So your base points are completed. Okay. So after this, you take A dash and O dash distance. A dash as the center, you draw one arc somewhere else here. Okay. Similarly, C dash D dash to O dash you take distance. From this point, you cut an arc. Wherever these two arcs intersect, so that itself is your O dash. After getting this O dash, so join all the corners. and also see to that it has to this axis line should pass it through this G dash point. So like this you have to redraw. I'll explain it once again. So till you have understood how to get this A dash and G dash right, after getting this, to get other points, you take this G dash to A dash distance with the help of your compass. From G dash you cut this uh, G dash to A dash, you know, G dash to C dash and D dash distance you take, draw an arc here. Then A dash to C dash and D dash distance you take, from here you cut an arc here. You will get the intersection point wherever you are getting it, you will get C dash and D dash. Now you join it, join this line. So the entire base you got it here. You take this distance from one point to other point and mark all the other points like this here. Okay. After this, to get the apex point, A dash to O dash distance you take, this is the center, you cut an arc. Similarly, C dash D dash to O dash you take and cut an arc. Wherever it intersects, so this is your O dash. Now join it to all the corners without changing its shape and size. An axis line has to be passed through on this G dash. This O dash to O1 should be passing through the G dash. So like this you have to redraw. So you should not touch XY line. So it is freely suspended like this. So corner position you have taken like this. I have tilted in this case like this. Okay. It is freely suspended in this case. So now to draw the top view for this, you keep on draw the vertical projectors from all the points like this one by one, and draw the horizontal projectors also like this. Coincide the points now. A is here, A dash is here, this is A. B is here, B dash is here, this is B. C is here, C dash is here, this is C. D is here, D dash is here, this is D. E is here, E dash is here, this is E. Base point O1 is here, O1 dash is here, this is O1. Apex point O is here, O dash is here, this is O. And now you have written the, you have drawn the front view like this. You are looking from here for the top view. Whenever you are looking this particular the front view from this direction, that is top side, the complete base you can see for this freely suspended type. So which is your base? A, B, C, D, you make it a visible edge. All the base edges we can see in this case. Since you are looking from here, the base of the pyramid you can see, it is like this. See, I freely suspended it like this. When you are looking from here, so the base you can see. So A, B, C, D, E, you can make it a visible edge. Coming to the slant edges, all the corners of your base should be joined to your vertex or apex. No, you are looking from here as usual. A to O you can see visible edge. D to O and E to O also you can see. E to O, B to it becomes outermost boundary, right? And you are looking from here, C to O and D to O. Can you see this two edges? No, you cannot see. So that's why D to O and C to O are hidden edges. And coming to the axis line, O dash, O to O1, you can represent the complete axis line. You cannot show because already O to O visible edge is there. Only A to O1 you can show the axis line representation. So this completes the top view. Okay. Next, the third position, it remains same. Not much the impedance is required in this. Okay. So the third case, what he has given. So the axis appears to be inclined at 45 degree as given. Correct. So appears to be in this case he has given. That means to say, so straight away directly has given the apparent inclination only. It is not the true inclination. So without taking locus, I have to incline this. Okay. So right side you take 45 degree line from any point of the XY line, and here just for a change. So in all the other pyramid example, apex we were writing apex towards the XY line, correct? Here also you can do it, no problem. Okay. So you can incline, you can draw 45 degree line in this direction. You can take the apex here and you can draw it. There is no wrong in that. So just for a change. So in this case, the base towards the XY line I am taking, just to make you understand the other alternate also. Okay, so I have taken the 45-degree line. No need to take the locus because he has given axis appears to be inclined at 45-degree line, right? So after taking it, so let me take this base point, that is O1. I'll take any one point on the 45-degree line. I'll call that as the O1 axis point. Now I'll take O1 to O distance. O1 to O distance, I'll take this O1 as the center. I'll cut this 45-degree line. I'll get point O. So what exactly you need to do it? So you have to redraw this. The previous top you set that O to O1 should lie on this 45-degree line. This is what you have to do it. So O1 and O, I have drawn it on the 45-degree line. Okay, I have drawn it on the 45-degree line. So after this, so I need to get other points. So you can use your own methods to redraw it. So O to O1 you know here. Okay, and extend this line here. O1 to A you can get it on the same line. O1 to O distance you take from O1 you cut it here. A will be getting it. How to get the other 4 points? O1 to this distance you take. O1 to this distance on 45-degree line. From this point you draw perpendicular line on 90-degree line. From here you take this D distance, from here C distance, it is one and the same. Cut it on either side of that perpendicular line, you will get C and D. Similarly, how to get this E and B? So you take this O1 to this distance or A to this distance you take. Somewhere else, draw 90-degree line, which I have not drawn here. On that 90-degree line, you take that point to E, this point to B distance. Cut it on either side, you will get B as well as E also you are going to get. So all the points you got it without changing anything, including the visible edges as well as the hidden edges, you need to redraw here. Once it is ready, then you can draw the final front view while drawing the vertical projectors from all the points like this. You can see 1, 2, 3, 4, 5, 6, 7. 7 point, and here horizontal projector from all the points you can draw it here. Coincide the points one by one. A is here, A dash is here, this is A dash. B is here, B dash, where is B? B is here, B dash is here, this is B dash. C is here, C dash is here, this is C dash. D is here, D dash is here, this is D dash. E is here and E dash is here, this is C dash. And O1 base point is here, this is O1 dash. O is here and O dash is here. Okay, after this, so here the apex towards you have written and the base towards the XY line you have written. That's why all the base point you cannot see. You are looking from here. You are looking from here, correct? So B2. So here the naming little bit. So it is changed. So these 2 points you can see D to E, A to E you can see, and A to B also you can see. A to B you can see, A to E you can see, and which is the other one? D to E also you can see. The remaining thing is the 2 edges B to C and C to D. This is B to D, C D, D to C as well as D to E you cannot see. So these 2 edges are hidden edges. That is what it is represented here in this. So your naming a little bit it is changed. While drawing it, you follow the method. Okay, and axis point from here to here, you draw the axis line representation. That means 2 base edges. Here I will show you. Okay, 1, 2, 3, 3 base edges you can see because it is nearer to you. This and this base edge you cannot see, which is represented here. Coming to the slant edges, so this slant edge you can see. Yes, this also you can see it becomes outermost boundary line. This also you can see. Only thing is you cannot see is that this one that is represented here. Only one slant edge you can see. All other 4 slant edges you can see. Okay, by practice, so you have to understand this. So this how a special case wherein a pentagon pyramid which is freely suspended from the base corner is the orthographic projection is done. Okay, same example you try it for the square pyramid also same. Instead of 25 millimeter, you take 35 millimeter base edge, and axis 60 millimeter you take, and same inclination you take, and try out this. Take this as the assignment. The square pyramid of 35 millimeter base side and 60 millimeter axis. Okay, you can consider, and the remaining thing remains same, so you can do it. Okay, so one more example, hexagon pyramid freely suspended, we'll discuss for today. Okay, so what he has given, hexagonal pyramid, 25 millimeter base of side and axis 50 millimeter length is freely suspended from its corner. You can suspend freely only from the corner. From edge we cannot suspend it. Okay, so this you have to remember. For freely suspended examples, you have to take the corner condition only. Draw the projection of the pyramid when the axis appears to be inclined at 45 degree line. Same, it is given. First, you draw the hexagon in the top view, such that the corner should come right side of you. That is what I have drawn here. So you know how to draw the hexagon with the help of the circle method. You draw a circle and construct the hexagon such that the corner, any one of the corners should come right side of you, and name it all the points in whichever way you want, and join the opposite corners, that is the diagonals, with a visible edges only, because in any pyramid in the top view, true shape top view, the slant edges will look like a lines. Okay, which is drawn from the center to the your corners. So you have to draw the visible edge thick lines only for this, and front view for this, draw the vertical projectors from all the points like this, and this is your axis point. Extend this axis point vertically upwards like this, and axis height is given 50 millimeter. You cut 50 millimeter on this axis line and call it as the axis point O dash. Okay, after this, from this apex or vertex point, you keep on join it to the all the points. Since you are looking from here, A, B, C, D, you can see, you cannot see E and F. E and F should be written within the bracket. Okay, and here also, before proceeding to the second position where we have to freely suspend the corner, we need to draw the constructional lines. That means we need to find out the center of gravity of this hexagon pyramid. So it is true for all the pyramids. So for all the pyramids, center of gravity lies in the axis line only, and that too 1/4 the distance of the axis from the base is concerned. So what is the total? This is the axis line. O dash to O1 is the axis line, correct? And then 1/4 of the distance means 50 divided by 4, 12.5. So from base I have taken 12.5. I have cut this point and call this point as the center of gravity point, that is G. So since it is front view, I'll call it as a G dash. Now you draw a construction line from G dash, center of gravity line, to the corner where I have selected and where I am the suspending it. So I have taken the corner as on the right side corner. So I have drawn the constructional line from A dash to G dash. That's all. So this is the construction work that you have to do it. Next, similar to the previous example, what we have discussed, right side, take some height from XY line so that it should not cross this touch XY line. Take any one of the point and call that as the corner A dash, because we are suspending the base of the corner of the your hexagon pyramid on that particular point, A dash point. Okay, from A dash point you draw a vertical line, the vertical line such that it should be perpendicular to your XY line. And this vertical line, what you need to do it, so you have to take this A dash to G dash distance. You have to take A dash is the center, you cut this distance and vertical line. Okay, A dash G dash distance, you cut it here and call it as the G dash. So A dash D dash marked here. I need to redraw this triangle, that is previous front view, such that this A dash G dash should coincide on this A dash and G dash. So how to redraw it? The same procedure will follow here. I know A dash and G dash, correct? I'll take this distance G dash to this D dash. From G dash, I'll cut an arc somewhere right side. Okay. After that, I know A dash to D dash distance also. From here, I'll take this A dash to D dash distance. From here as the center, I'll cut this. So wherever these two arcs G from G and from A to your D, I'm getting the intersection point. You call that as the D dash point. Once you get the D dash point, you join this A dash and D dash with a visible edge. Once you get this line, you take the corresponding distance from all these points and transfer the corresponding points also here. Once this A dash and D dash is known, you take this distance, corresponding distance with the help of your compass, keep on cut on this and transfer the corresponding points also there. And how to get the apex point now? The base point you know, okay? So A dash to O dash distance you take, A dash as the center, you cut an arc, or any method if you want, you can use it, okay? And D dash to O dash distance you take, D dash to O dash and cut an arc. Wherever these two arcs cuts, that is your O dash. Now from O dash, all the corners you can join with the visible layers. And axis point also you can join. Definitely it has to pass through on the center of gravity point, that is G. So this how you have to redraw the the front view such that the A dash and G dash should coincide on this the line which I have drawn here. That's all. Okay. After this, you know how to draw the vertical projectors from all the points of your front view like this, and draw the horizontal projectors also from all the points. Now coincide the points. A is here, A dash is here, B is here, B dash is here, C, C dash, D, D dash, E, E dash, F, F dash, base point O1, O1 dash, apex point O, O dash. After getting all the points for freely suspended type, the entire base is exposed top. That is, it is towards you. You are looking from top. The complete base you can see. Second position, top view. That means A, B, C, D, E, F. You can make it a visible edge. After this, we will consider the slant edges. That means all the corners of the base to the your vertex. You are looking from here. A to O you can see. Draw the visible edge. B to O, F to O also you can see. Becomes outermost boundary line. And can you see C to O and E to O? You cannot see. Draw the hidden edges. And D to O also you cannot see. But D to O completely I cannot draw the hidden edges because A to O already visible edges there. That's why from D to A I can show the hidden edge. And axis line also I cannot show the axis line representation because already visible edges here. So this completes your the top view of this, the hexagon pyramid freely suspended one. The third position. So here also he has given axis appears to be inclined to VP at 45 degree line. 45 degree is given with respect to VP. Right side you take 45 degree line with respect to XY line in any direction. So here also, so I have taken this example, the base is towards the XY line. So in most of the example, that also you can try the final position, it is left to you. Whether the apex you are writing towards the XY line or base you are writing towards the XY line, that is left to you. If the apex is written towards the XY line, the entire base you can see. If the base is towards the XY line, few portions of the base edges that you cannot see. Here also let me take the same example. So base is taken towards the XY line. So I have taken 45 degree line to XY line, right? So I will take O1 axis base point on that 45 degree line and I'll mark that as O1. Now I'll take O1 to O distance, I'll take on the axis line. O1 as the center, I'll cut 45 degree line. So I'll be getting O. I'll be getting O. So after getting this, that means why I am doing this, I need to redraw this the top view such that O1 and O should coincide on this. The 45 degree line should come. That's all. So O1, O you know, on the same line, O1 to D distance you take, and cut it here, you will get D. Same distance O1 to A, you can cut it on the other side, A you will going to get. So the same line OA, O1 and D you can get it. How to get the other 4 point E, F, B, C? The same line A to this distance you take and D to this distance you take. A to here and D to which are not shown here. Draw perpendicular line. After drawing perpendicular line, from here to F it is same, from this point to B the distance is same, from this point to E distance is same, from this point to C distance is same. You take that distance and cut it on either side here, from here you cut it on either side, or your own method you can use it to redraw it. So you're going to get all the points without changing anything, you redraw it, the shape as well as the size. So this completes the top view. Coming to the final front view, you keep on draw the vertical projectors from all the points like this. Draw the horizontal projectors also. So coincide the point. A is here, A dash is here, correct? B is here and B dash is here. This is B dash. C is here and C dash is here. This is C dash. D is here, D dash is here. This is D dash. E is here and D dash is here. This is C dash. F is here, F dash is here. This is F dash. O is here, O dash is here. This is O dash. Base point O1 is here, O1 dash is this is your O dash. Now all the base points first you join it, and then all the corners of the base should be joined to your vertex. So you are looking from here B to C. You can see the base edge. B to C is visible. A to B also you can see visible. A to F also you can see visible. The edges that you cannot see is F to E and E to D. F to E, E to D, you cannot see, those edges are to be hidden. And coming to the slant edges, you are looking from here, O to B you can see, and O to A also you can see, O to F also you can see, and it becomes outermost boundary line. O to C also you can see. The only one the slanted that you cannot see is nothing but O to E, which is behind you, O to E. And axis line you can join it from O1 dash to O dash. So this how the freely suspended the exercises are to be drawn. So the two examples I have drawn. One more I have given assignment. A square pyramid, it is easy. You take 35 millimeter as the base side and axis 60 millimeter. Repeat the same the procedure, the same question, inclined at the 45-degree line. So like that you have to complete it. So this completes the freely suspended examples also. So in the next class, that is tomorrow class, so we